this video, you'll learn about an important integration technique called integration by parts. If the integrand is the product of two functions, one is named f and the other is the derivative of a function g, then this pattern qualifies for integration by parts technique. Let's learn how to recognize the pattern. For example, if the integrand is x times cosine x, I'll make this product follow the pattern needed for integration by parts. As the antiderivative of cosine x is sine x, I write the given integrand as x times the derivative of sine x. If the integrand is x times sine of x, I'll express it as a product that follows integration by parts pattern. We know the antiderivative of sine x is minus cosine x. I write the integrand x times sine x as x times the derivative of minus cosine x. The integration by parts technique can be used when the integrand is the product of two functions. One is the derivative of a function f and the other is a function named g. For example, if the integrand is x times ln of x, I'll make this product follow the pattern needed for integration by parts, namely the product of two functions, one being the derivative of a function f and the other a function g. As the antiderivative of x equals x squared over 2, I write the initial integrand as the derivative of x squared over 2 times ln of x. If the integrand is only ln of x, I make this into a product, the product of 1 and ln of x. As the antiderivative of 1 is x, I can write the integrand ln of x as the derivative of x times ln x. This is the product of two functions, the derivative of f times g as it's needed for integration by parts. So, it doesn't matter the order of the two functions as long as one factor is a function and the other factor is the derivative of another function. Let's see what integration by parts theorem states. If the integrand is the product of two functions, a function named f and the derivative of a function g, integration by parts theorem states that the result is the difference between the product of functions f and g and the indefinite integral of the product of the derivative of function f and function g. To evaluate the indefinite integral of x times cosine x, the first step is to write the integrand as the product of two functions, f and the derivative of a function g. As the antiderivative of cosine x is sine x, I write the integrand x times cosine x as x times the derivative of sine x. It follows that f of x equals x and g of x equals sine of x. The result is the difference between f times g, x times sine of x, and the indefinite integral of the derivative of f times g, the indefinite integral of 1 times sine of x. Integration by parts has worked as the resulted indefinite integral is of sine of x, which equals minus cosine of x. On the second example, I'll evaluate the indefinite integral of x times ln x. The first step is to write the integrand as the product of two functions, one being the derivative of a function f and the other a function g. As we know, the antiderivative of x is x squared over 2. Therefore, I write the integrand x times ln x as the derivative of x squared over 2 times ln x. It follows that f of x equals x squared over 2 and g of x equals ln x. The result, based on the theorem, is the difference between f times g, x squared over 2 times ln x, and the indefinite integral of f times the derivative of g, where the indefinite integral of x squared over 2 times 1 over x. Integration by parts has worked, as the resulting indefinite integral is of x over 2, which equals x squared over 4. Integration by parts works for the following integrands: the product of x and the function h, where h of x can be either e to the power of x, or sine of x, or cosine of x. To create the integration by parts pattern, h of x is replaced by the derivative of function g. You find function g evaluating the antiderivative of function h. When h of x equals e to the x, then g of x is the antiderivative of h, which equals e to the power of x. When h of x equals sine of x, then g of x is the antiderivative of h, which equals minus cosine of x. When h of x equals cosine of x, then g of x is the antiderivative of h, which is sine of x. Integration by parts works for the following combinations: the product of x and the function g, where g can be either ln of x, arcsine of x, arccosine of x, or arctangent of x, or arccotangent of x, or arcsecant of x, or arccosecant of x. To create the integration by parts pattern, x is replaced by the derivative of a function f. You find function f evaluating the antiderivative of x, which equals x squared over 2. Then you apply the integration by parts theorem. Integration by parts also works for the following integrand: the product of 1 and a function g, where g of x can be either ln of x, or arcsine of x, or arccosine of x, or arctangent of x, or arccotangent of x, or arcsecant of x, or arccosecant of x. To create the integration by parts pattern, 1 is replaced by the derivative of a function f. You find function f evaluating the antiderivative of 1, which equals x. Integration by parts works for this combination: the product of e to the x and sine of x. To create the integration by parts pattern, sine of x is replaced by the derivative of minus cosine x. The result is e to the x times minus cosine x plus the indefinite integral of e to the x times cosine x. To solve this last indefinite integral, cosine x is replaced by the derivative of sine x, and I'll apply again integration by parts. In this process, I end up with the same integral I started with: the indefinite integral of e to the x times sine of x. When the indefinite integral we need to evaluate shows up in both sides of the equation, see here I linked the first integral with the last one. I created equation 1. So when the indefinite integral we need to evaluate shows up in both sides of the equation, move the one on the right side to the left side of the equation. So we have to move this one to the other side of the equation, and then put them together as like terms. Finally, Divide by 2 on both sides of the equation to find that indefinite integral of e to the x times sine of x equals 1/2 of e to x times minus cosine x plus 1/2 of e to x times sine of x.